Hello students, welcome to Adangal. Good evening to all.
Good evening, sir.
Good evening everyone.
Good evening, sir.
Good evening, sir.
Good evening.
Good evening, sir.
Good evening Kapil.
Good evening, sir.
Good evening. So today first of all we will drive by important. Please
Good
mute
evening,
your. So we will drive the relation for the temperature of the mixture when two gases are mixed together. So two ideal monatomic So we have to calculate the temperature of the mixture. Most important thing to note is monatomic gases, and there is no loss of energy when they are mixed. Now, because their temperatures are different, and we know that the energy of the gas it is dependent on the temperature, and because both are monatomic, so both are having 3 degrees of freedom. So kinetic energy of first gas. What is the kinetic energy of first gas according to you? And then kinetic energy of second gas. Who will tell me?
3 upon 2 kT.
Yes, very good. 3 upon 2 kT1, and here it will be 3 upon 2 kT2 because their temperatures were different. And now this is for one molecule, na? And it is also given that they consist of N1 and N2 molecules. So it means the correct expression should be this, and for the second case it will be this. Am I right?
Yes, sir.
So therefore, total kinetic energy of gases before mixing, it will be sum of these two. N1T1 plus N2T2. Let it be number 1. So now let us assume that after mixing, the temperature of the mixture it becomes T, capital T. Okay? Clear?
Yes, sir.
Then what will be the energy of the two gases after mixing? Of the mixture be T. After attaining equilibrium, obviously. What kind of equilibrium? Because we know that whenever we mix two things at a different temperature, then heat flows from a hotter body to colder body till their temperatures become equal. Okay? So this phenomena will occur, and obviously after some time, both the gases they will attain same temperature, and that is what I'm calling as equilibrium. Because then no more heat will flow from one body to another, na? Because temperature difference has become 0. Okay? Clear or not?
Yes, sir.
Initially, there are two gases. This is one gas, gas A. This is another gas, gas B. This was at temperature T1 and T2. Suppose T1 is greater than T2. Then the heat will flow from this to this. But eventually, after some time, when both attain the same temperature, now no heat will flow. Na?
Yes, sir.
So kinetic energy of second gas. So total energy. Number 2. And we are given that there is no loss of energy. So total energy before mixing should be equal to total energy after mixing. Okay? So now we can equate two expressions. Na? Therefore, 3 by 2 N1 plus N2 KT should be equal to, yes, Usman, 3 by 2 K N1 T1 plus N2 T2. So now 3 by 2 K factor will get cancelled. So this gives us N1 plus N2 T, N1 T1 plus N2 T2, and hence T is So this is the important result. Temperature of the mixture. Now let us generalize this formula. So this was for monatomic, but the gases can be polyatomic. For example, one gas can be monatomic, other can be diatomic, or other can be triatomic or polyatomic. It's like that. Then what has to be done? Let us again make it into the form of a question. With degrees of freedom T1 and T2 are mixed so that there is no loss of energy. If the number of molecules, no need to write mass now, because it is dependent on the number of molecules of the two gases are N1 and N2 respectively, temperature of the mixture. Now what about the first gas? What will be the energy of the first gas? Yes. Very easy, just like the earlier one.
1 kb.
3 by?
2 and 1 kb.
No. Why it should be 3 by? Why polyatomic, na?
5 by 2 and 1 kb.
How much?
5 by 2 and 1 kb1.
Why 5 by 2? That is for diatomic, na?
The F by 2 too.
Yes, F1 by 2. I think I forgot to write degrees of freedom. Oh, please add with the degrees of freedom of the molecules of the first and second gas respectively as F1, F2. Okay, please add this. I forgot to give you the degrees of it. Otherwise, also it is polyatomic. So it should be F. So for first gas, it will be F1 by 2, N1 KT1. Kinetic energy of second gas. F2 by 2, N2 KT2. So what is the total energy before mixing? You will just add them up. This, na?
3 by 2 नहीं आएगा.
Yes.
3 by 2 नहीं आएगा.
Oh, sorry. It should not contain 3 by 2. Actually, yeah, it is K by 2 only. Na? F1, N1, T1, F2, N2, T2. Okay. So let the final temperature of the mixture after attaining equilibrium Pt, then so obviously this K by 2 factor will get cancelled. And now we can get T. Yes, Divya and Jashri. So now you need to remember this formula. Actually, why I have derived this formula, so that you can remember it and you can get the answer very quickly in the exam whenever two gases are mixed. So now it is a generalized formula for polyatomic. So T will be F1 N1 T1, F2 N2 T2 by F1 N1 plus F2 N2. Please check everyone. Now let us see. Let us see how we can make use of these results in the examination. I have one example for you. Okay, so try to solve that. 1 gram Now, please get me the answer.
Sir?
Yes.
So for polyatomic gases, we should only take the translational degree of freedom, sir. For the previous question, sir.
No, they are the total degrees of freedom. I never said it is only translational. Please read the question carefully.
Okay, sir.
These are total. Of course, they depend upon temperature. Now we have seen yesterday that your vibrational degrees of freedom, they only contribute at higher temperature.
Yes, sir.
But at normal temperature, you should take into account both translational plus rotational. Okay.
Okay, sir. Okay, sir.
It means this F is both translational and rotational, you can say. Vibrational are not included at normal temperature until or unless it is being mentioned that the temperature is very high. Only then we will consider the vibrational one, otherwise not.
Okay, sir. Thanks, sir.
Now, the very first thing you should take care is you have to convert the temperature into Kelvin. Only then you have to solve. Okay. Please don't do the calculations with temperature in degree centigrade. Otherwise, you will end up getting the wrong answer. Yes, Divya, very good. No, Abhay, please check your answer. Now, first of all, both gases are monatomic. It's wrong, Mamta. So when both the gases, they are monatomic, we need not consider. Yes, Rita is correct. Sanju wrong. Divya is correct. Yes, Prachi. Yes, Kapil. Good. Now we can straight away use this formula. And 1 mole of both, it is being taken. It's wrong, Jayashri. Yes, Gomti. This is the answer. Clear?
Yes, sir.
Now another one.
Sir?
Yes.
Sir, 1 mole के लिए N1 N2 Na लेंगे ना Avogadro number से.
Then what? Even then they will get cancelled. In the denominator also you will take Na plus Na then. What is the
Yes, sir.
difference? Even then you will get a factor of 1 by 2. Na?
Okay, sir.
Answer will be same whether you take it as Na or not. Now be careful while doing the calculations. Yes, Umesh. Yes, Prachi, correct. It's wrong, Satish. Yes, it's wrong. Yes, Kapil, correct. Yes, Divya. Yes, Rita, correct. Yes, Usma, you can say. Yes, it is correct. No, Smruti Shri, it's wrong. Oxygen is diatomic and helium is monatomic, first of all. It's wrong, Ritika. So 5 degrees of freedom, 1 mole. T1 is 27 plus 273. And 3 degrees of freedom, 2 mole. Temperature is 127. Yes, Sumira, correct. So it will be 5 into 300, 6 into 400, 5 plus 6. So 1500 plus 2400 by 11. 3900 by 11 Kelvin. So it is 354.5 Kelvin, which is equal to 81.5 degrees centigrade. Please check. Now you can check. Clear?
Yes, sir.
Yes, sir.
Now one question similar to the question that we did yesterday. Let us see who is able to answer. Mixed then the ratio of so please try to calculate. So today I will give you another formula also for calculating the gamma for the mixture in a shortcut way. But try to solve it first. Yes, Mamta, very good. Yes, Jashri. Yes, Divya, very good. Yes, Prachi. Let me give you the shortcut formula. You can note down gamma mixture. It is N1 gamma 1 by gamma 1 minus 1, N2 gamma 2 by gamma 2 minus 1 when two gases are mixed. N1 by this, N2 by this. This is the way. So in our case, N1 is 2 moles. And what is gamma 1 for diatomic? This, and for monatomic, 1 mole. And gamma 2 is 5 by 3. 1 plus 2 by F. 1 plus 2 by 3, 5 by 3. Okay. Now put these values. That's it. To get gamma mixture. This will be the answer. C option, 19 by 30. Please note down. You can do by yesterday's method also. Even then you will get the same answer. Note it.
Yes, sir.
N1. 2 into 7 by 5. Answer. You can check. Clear?
Yes, sir. Now this is an important question. Temperature is much higher than the vibrational and rotational energy scale.
Sorry, it is energy. But lower than its bond dissociation energy, means bonds will not break, but molecule can go through all kinds of possible motions because the energy is lower than the bond dissociation energy. And the diagram is this kind of molecule is there, non-linear. It means the vibrational degrees of freedom will also contribute. It is very much clear from the question itself. Of course, we are very much sure about the translational and rotational degrees of freedom. Okay, so translational are 3 and 3 will be rotational because now it is triatomic, isn't it? And how many vibrational, how many bonds are there? 3, na?
Yes, sir.
But each vibrational degree of freedom will contribute kT. This you have to keep in mind. Okay. So what will be the answer according to you? Very good, Siddesh. No, Divya, it's wrong. Yes, Jashri. Uzma, it's wrong. It's wrong, Dima. Very good, Ramdayal. Someshwaran, Prachi, it's wrong. Good, Arun. Yes, Sanju. Very good, Tapel. So option D, I have explained this clearly. Rita, it's wrong, but still, I don't know why you are getting the wrong answer. In fact, I can give you the I gave you the number also of the degrees of freedom. U will be F translational by 2, F rotational by 2, plus F vibrational kT. So 3 were translational, 3 were rotational, and 3 were vibrational. So it is clearly 6 kT. So CV is du by dt. 6 kT. This is the answer. Okay. Clear?
Yes, sir.
If it was linear,
Your voice is breaking. I'm not able to listen properly.
so I'm asking that if it was a linear, so can you hear me now?
Yes.
If it was a linear molecule, then what would be the value of the vibrational degree of freedom?
Okay, let me tell you. There is a formula for calculating the vibrational degrees of freedom. For non-linear, let me tell you. For non-linear molecule, vibrational degrees of freedom are given by 3n minus 6. In this case, n is 3. Na? Therefore, F vibrational. This is how I got 3 degrees of freedom. Okay. For linear molecule, it is 3n minus 5. Okay now?
Yes, sir.
But there are other modes available also. Actually, it is a very much deep topic. So there are various kinds of modes. These I'm talking about only normal modes. Normal modes are those modes in which center of mass of the molecules it remains fixed. Okay.
Okay.
Center of mass means molecule it vibrates in such a manner that the center of mass it appears to be fixed. Only those modes are being considered. But if we are considering those modes also in which center of mass it is getting displaced from its position, then obviously more number of modes are there. Okay.
Okay, thank you.
For example, for water, it is a non-linear. Na? So according to the formula, we should have 3. But actually there are more. Have you Googled it yesterday? I told you people. So that please Google it and see how the molecules they undergo different kind of vibrations. I don't think so. No, na? So do it today. If you have not done, then do it today. Okay, you will get some extra knowledge. Okay.
Okay, sir.
Because it is not possible to make it here. Na? So videos are available. Number of atoms and not number of bonds. That's why that 3n factor is there, na? Because of 3D. In 3D for n molecules, the max number of degrees of freedom can be 3n. Na? Actually, we are subtracting translational plus rotational out of total degrees of freedom. 3n are the total. So for non-linear, translational plus rotation was 6. Na? So that's why we subtracted 6. But for linear molecule, there will be 2 rotational degrees of freedom and 3 translational. That's why we are subtracting a factor of 5 out of total 3n degrees of freedom. Okay. That's how this formula comes. No, sugar. It's not that. Of course, there is a topic degrees of freedom in classical mechanics also, but here we are talking about the gas molecules only in general.
Okay, sir.
Their degree of freedom, they have a different meaning. Actually, their degree of freedom, they are related to the choice of the coordinates. Here we are not making the choice of coordinates by looking at the degree of freedom. Okay. Of course, there also we will discuss degrees of freedom, because there we have to make it into the equation of motion. So that's why we look for the generalized coordinates. It means if degrees of freedom are 2, it means for that system I require 2 coordinates to specify its motion. Okay. So totally different viewpoint is there. Now, please try to solve this one. Only translational and rotational you have to consider. And it is a linear molecule, now obviously diatomic. So it is very much clear. Yes, Arun, very good. Yes, Siddesh. Very simple question. Clear?
Yes, sir.
No. Answer this one. This is from IIT Jan. No, Sanju, it's wrong. Never be in a hurry. Yes, Siddesh, Arun, Uzma, Divya, it's correct. Rita, it's wrong. Yes, Abe, Prachi, Somesh, it's correct. Very good, Ramdhyal, Mamta, Umera, very good. Yes, Jashvi, correct. It's wrong, Satish and Himanshi. Can you explain it? Your answer, Satish. Can you explain it? I'm asking you, speak up. Are you listening to me, Satish? He's not answering. Then please speak up now. I'm asking you something. What about you, Himanshi? Can you explain it? I need to know now what you people are thinking.
Yes, sir.
Explain it.
Sir, actually here it is 5 by 2 R. So we can think that 5. So FR can be 2 and F translational will be 3. So in total F is 5.
Yes.
So that's why I thought that they are definitely rigid diatomic.
Okay. Then what about monatomic case?
So they will.
Yes.
So there will be 3 by 2.
But that will be CP. Now, if you calculate CP, it will
Yes,
be
sir.
5 by 2 R.
Yes, sir.
So it can be both, na, monatomic or rigid diatomic.
Yes, sir.
Because it is clearly given in the question that it is not specified that they are talking about CP or CV.
Yes, sir.
So for monatomic, let me solve it. For monatomic, F is 3. So CV is, so U is 3 by 2 KT, NaKT for 1 mole, molar. Na? So 3 by 2 RT. So CV is 3 by 2 R. So this gives Cp, which is Cv plus R. It is 5 by 2R. So this can be monatomic. If it is Cp, if the information that they have provided, if it is Cp, then it can be monatomic. But if it is not Cp, if it is Cv, then for diatomic, we have F as 5. So U will be 5 by 2 NaKT, that is 5 by 2 RT. So here, this Cv can be 5 by 2 R. So therefore, gas can be monatomic, and this is for rigid. Okay, monatomic or rigid diatomic. Because for both, we are getting 5 by 2R as a possibility. Okay. Now another one from IIT Jam. A box. Now that formula will come into play. That formula that we had derived today in the beginning of a diatomic ideal gas. How do you know that for diatomic non-linear molecule it is 3 kT? Divya, how do you know? I'm not getting you. That 3p minus c, do you know which degrees of freedom they are included in 3p minus c? Only translational and rotational are considered. Even by using that detailed formula, you are still getting 3 kT. There is no confusion at all. You are yourself falling into confusion by remembering the formula only. That 3p minus c is only translational and rotational. And here also, if you consider only translational and rotational, you will get 3 by 2 kT plus 3 by 2 kT, it will be 3 kT. So in that question, we have included vibrational. That's why it was 6 kT. That 3p minus c formula does not include vibrational. Welcome, beta. This is from IIT Jam. It means boxes, they are not absorbing any energy. And it is clearly given. We can ignore the vibrational. Yes, Somesh, it's correct. Uzma, it's wrong. This is not in the option that you are saying, Uzma. Yes, Jayashri, it's wrong, Tamya. Very good, Abe, Sanju. Very good, Prachi. Yes, Mamta, it's correct. Very good, Ramdal. Very good, Divya. Yes, Samruti Shri Arun, very good. So option C is correct. Let's see how. Very good, Rita Kapel. So T mixture was, yes, Sumira, F1 N1 T1 F2 N2 T2 by F1 N1 plus F2 N2. Na? So first gas is diatomic. It is P naught. Second gas is monatomic, 2 moles, 5 T naught. Na? Is it? So you can see how useful that formula is. Na?
Hello, sir.
Yes.
Sir, yeah, we know that the degrees of freedom for monatomic gas is definitely F equals to 3.
Yes.
If there the vibrational kinetic energy contributes, then will there be any change in degrees of freedom?
Monatomic cannot vibrate. Na?
So why?
It is only one molecule. Is there any bond? Monatomic means single atom, na? How will it vibrate? Vibration can only occur when there is a bond between the two atoms. Vibration means the distance it is changing.
So, but it itself can make a vibration.
That is not considered as vibration. That will be translation only. Na? When it is getting displaced from its position. Either you consider that as translation or vibration. Vibration means the molecule is at its position, but only these two atoms, they are changing the distance between them. That is called vibration. If it is moving along this side,
It's a
then
translation. Okay.
it will be translational only.
Now we can consider it. Okay, thank you.
So it means it is triatomic, rigid. Yes, Uzma, Sanju, Siddesh, Arun, Abe, Divya, everyone correct. Yes, Yashri, Kapil, Tanmay, it's wrong. It's wrong. Yes, Rima, very good. Yes, Someshwaran, Rita, it's wrong. Very good, Tanmaya, Mamta. How many degrees of freedom are there?
6.
6. Then U will be 6 by 2 RT. CV will be 6 by 2, means 3 RT. Na? So it will be 3 R. So CP will be 4 R. That's it. So many times I have announced that you have to consider the vibrational degrees of freedom only when it is given. Only when it is given that the temperature is very high, just as we did one question. Otherwise, we have to consider only translational and rotational. Clear? Now there is another one in IIT Jam 2018 related to this. An ideal gas consists of 3-dimensional polyatomic molecules. The temperature is such that only one, now see, it is clearly given, only one vibrational mode is excited. Yesterday also I said that these vibrational modes, they are having different energy. They are getting excited at different energies. So only one is getting excited this time. It means for others we require still more energy. The energy is not sufficient to excite all the vibrational modes. Only then those are different modes. Na? Different mode means obviously they can have same energy also, but in general they will have different energy. Yes, Sanju, Uzma, Divya, Siddesh, Yashri, Abe. Abe, it's wrong. Mamta, correct. Ritika, it's wrong. Arun, it's correct. Rita, Samruti, Shri, it's wrong. Yes, Tamya, Abe, correct. Very good. Polyatomic molecules. So how many total modes are there for polyatomic? Anyone? So let us calculate U.
3 translation, 3 rotational, and 1 vibration, sir.
Yes. This will be the formula.
Yes, sir.
Let us write it RT only, because for one more we have to do it now. So only one, it is given. So it will become 4 RT. So CV is clearly du by dt That is 4R. That's it. Quite a simple question. Please check. Clear?
Yes, sir.
Yes, sir.
So what does it mean by RMS distance?
Distance of all the particles, it will be different. No? So when the distance is different from the origin, then either you take mean, but when the mean is not able to give you the meaningful information, then we take RMS value, no? Just as you do for velocity, VRMS. So same thing is about the distance here. Okay. And why we calculate RMS? Because particles, they are vibrating around their mean position. That's why always RMS distance is being taken. And RMS means square, then mean, and then root. No? It means your RMS square. R RMS square will be what? It will be x component square mean, y component square plus z component square. No? Because R vector is of the form xi, yj, zk. So R square will be x square plus y square plus z square. No? And according to this equation, can I write that this is equal to 2 by lambda into V? Can I write like this? Yes.
Yes, sir.
And what is this
Sir,
quantity?
can you please repeat this mean?
Here in this equation, get the value of x square plus y square plus z square. You will get this now.
Sure, sir. Yes.
So because on the left hand side you are taking mean, these brackets mean mean. Na? So on the right hand side also there will be mean. But because 2 and lambda are fixed, so only thing we are concerned about the mean value of V. Na? And what is the mean value of V? Yes. What is the mean value of V? We know that each quadratic term, it corresponds to half kT, na? And V consists of 3 quadratic terms. So mean of V should be 3 by 2 kT, na? According to equipartition theorem, which says that energy associated with each degree of freedom is half kT. And there are 3 of them. Na? Means these are actually 3 energies. Na? Half lambda x square, half lambda y square, half lambda z square. This is one energy term, this is another, this is third one. Okay? Clear?
Yes, sir.
So now what is R RMS?
So option B. Sorry, option A.
Yes, option A. Square root. That's it. Clear?
Yes, sir.
Very easy question. Pressure, how pressure depends upon temperature?
So also
Directly proportional. No?
Proportional.
So initially the gas was at higher temperature, and you are lowering its temperature, so the pressure will decrease. So clearly C option. No?
Yes, sir.
Clear to everyone? Initially the gas was at temperature T, and T is greater than T1. The container is at temperature T1. So when the gas will equilibrate with the container, the temperature of the gas will fall, and hence the pressure will decrease. So it means the pressure will be higher at initial state than at the final state. Okay.
Yes, sir.
So that's all for today, students. So we will continue from here on tomorrow. Okay. Bye bye. Take care.
Thank you, sir.
Thank you, sir.
Thank you, sir.